Right. Hey everyone, it's Alex again, and today we're going to go over lesson 2 about power and sources. I should probably put that also. So basically, power is just the amount of work you do in an amount of time. You might know from a physics class that you've taken or whatnot, but right here we have the classic um, electrical engineering current times voltage equals power, and this is true always. And here we have different forms of that same equation, and we obtain these from using good old Ohm's law right here. So the first way of obtaining uh, the the way of obtaining this guy right here is you simply just plug in V into here, and you get P equals I times IR, which you can see will become I squared times R. And with a little bit of algebraic manipulation, you can divide both sides by R and get I equals V over R, and plug I into the power equation, and you get V squared over R. So cool. Power's a big thing, and it gets a little more complicated, but for now, at the very basic, this is all you need to know for power. Um, well, there is going to be another thing that I'm going to talk about power, but first we're going to look at source elements. So these are your most basic source elements. We have voltage sources and current sources. So a voltage source um, is something like a battery, um, the plug, your wall plug, or something like that, an outlet. Um, and as you can see here, there are two kinds of voltage sources, and this one right here, this one is mostly used for, um, most commonly for like a battery or something like that. Why? Because this represents a DC source. So a DC source basically is just a constant voltage source over time. There's no oscillations or anything like that. This oops, sorry. This right here would represent a an AC source, which we'll get into way later in this course or in this lesson series. Um, but for right now, all we care about is DC, which is just a constant voltage. So you have some constant voltage V. In this case, it's just 9 volts, and that's what this guy represents. Now, the circle can be AC or DC, and same for the um, the current source right here. AC stands for alternating current, and DC stands for direct current. There's no frequency associated with the direct current because it's just a straight line. Now, these symbols right here, the plus and minus, are very important in terms of the direction at which the current is going for a voltage source. So, if a current is going this way, then we have it going through the negative terminal and out the positive. But we can also have current going in through the positive terminal and out the negative terminal. And this is significant because of power. Now, as you can see here, P equals IV, but a more accurate equation is P equals plus or minus IV. Now, this is very important when determining, when doing calculations, because it's all a coordinate system. Electrons are typically assigned negative by us, but in reality, nature doesn't care if it's positive or negative. And so we assign this coordinate system as well. So for the sake of consistency, throughout this entire video lecture, I will be calling currents going into the negative end as negative. You're going to get a negative current, and currents going into the positive end as positive. And likewise, we can have a positive power or a negative power. So when power is positive, the component, or rather the source, is a passive element. Kind of like how in last lesson we talked about the passive sign convention of a resistor. Now, we know that a resistor removes energy, right? Or converts energy into its surrounding area. And so if you have a voltage source and it's going, the current is going into the positive end, then that means that this source is acting as a positive element and it is charging. It is absorbing the energy. Now, if we have P is less than 0, the source is an active element. It is generating. So I guess distributing. So if we have a circuit like so, and say that this resistor was a light bulb, then and we had our voltage source right here, plus minus, there would be a current going through like this, and we have a negative side, and so the current is going into the negative side, going out. So that means that this guy right here is generating the energy to light this light bulb, right? Now, if we have another scenario, we can say that we know that this guy is bigger than this guy, so the current is going to be going this way, and it's dominating this 5 volts right here, which has a current going in this way. But so right here, the current is negative, it's going in, so the power is less than 0 here, and the power is greater than 0 here. So then that means that this guy right here is being charged. This battery is being charged by this battery, right? And finally, we know that P can be negative or positive, right? So the total sum of all the P's must equal 0. This is conservation of energy, right? The amount of power generated to the amount of power absorbed or lost, right? They must be equal, or else you're creating energy which is illegal. So that's it for this video lesson. next lesson, we should be looking into Kirchhoff's laws, which will help govern how we observe and analyze more complicated circuits. All right, bye.